In this section, let's talk about daylight simulation in Climate Studio. There are two types of daylight simulations: point-in-time illuminance and annual daylight availability. Let's start with point-in-time illuminance, which simulates illuminance on a sensor grid at a specific moment of time. You can follow these 7 steps for daylight modeling and simulation. Model the geometries, assign layers to geometries, assign materials to layers, set up sensor grid, select project location, set date and time, and run simulation. Let's open Rhino and model a box with the dimensions of 10 meter by 20 meter by 4 meter with the narrower side facing south. In the front view, draw a rectangle that represents the boundary of a window. Split the box using the rectangle. Assign the window geometry to layer 3 and change the name of the layer to window. If you hide the window layer, you can notice that there is an opening in the box. This is one of the fundamental differences between daylight modeling and energy modeling. The newer version of Climate Studio automatically creates openings when exactly overlapping, but trimming is still a good practice. Let's change the other layers to wall, ceiling, floor, and shading. Explode the box into individual surfaces. Select all walls and set them to the wall layer. Select the ceiling and set it to the ceiling layer. Select the floor and set it to the floor layer. Climate Studio assigns materials by layers. The materials in Climate Studio are different than your Rhino materials. The material you assign for each layer in Climate Studio is the interior finish, not the structure or any other materials. Click on the point-in-time illuminance icon. Click on the Material tab. You can see that no material is assigned to any of the layers. Click on the None for the wall layer. You can select a material from the list here. These columns show the reflectance of each material. Search Paint and select the paint you desire. I'll select the blue-green painted walls. On the top left, the preview shows a rendering of the material. On the right, it shows the optical properties of the material. Click Select. You can see that the paint is assigned to the wall layer. Let's set materials for the rest of the layers. For the ceiling layer, select Acoustic Tile. For the floor layer, select a dark carpet. For the window layer, click on the drop-down box here and select Exterior Glass, then select a glass. After assigning materials, let's set a sensor grid to evaluate the illuminance. Let's select the floor surface and run Show DIR command in Rhino. The magenta arrows denote the normal direction of the surface, which is pointing downward. If you put sensors on this surface, all the sensors point downwards, which will result in 0 lux because there's no light coming from the bottom. Click on Flip Direction to flip the normal of the surface. Before we add sensors, let's set the viewport style to wireframe for easier visualization. Select the floor surface and click on the Sensor Grid tab and add sensor grid to this surface. I'll set the sensor spacing to 1 meter. Target sensor inset to 0.5. Sensor spacing refers to the distance here, and the sensor inset refers to the distance here. I'll leave the work plane offset to 0.75, which is the height for typical office tables. Click OK. Now, you can see that there is an array of light sensors in the room, 2.5 feet above the floor. Our daylight model setup is finished. Let's make sure that the project site location is correct. Then select the time and date you want to simulate. Let's select the summer solstice at noon. Leave the ground albedo to the default of 20%. Click this triangle to run the simulation. The results show that the mean lux is about 1600 and the median lux is about 130. In daylighting, median lux is often a better metric. If you hover your mouse over these sensors, you can read the illuminance for each of the locations. It should be obvious that there is often too much light near the window, and the light level dramatically diminishes as you move deeper into the room. One important note is that keep the min-max of the color legend to 0 to 1000. Otherwise, the interpretation of the false color changes.